So Sam is CEO at FLECS. FLECS is one of the actually brave early adopter of Zenoh. They also wrote a very interesting white paper justifying or explaining, their selection process. And we always look into performance, latency, throughput. But I think the comment that I liked the most in your white paper was the one on R&D team size and the fact that besides the performance, it was the easiest to do, that the easiest to use, and the one that you felt right, even a small R&D team could be successful with. Okay, without further ado, Sam, the stage is yours. I'll eclipse myself, but I'll remain here looking at your presentation, and I'll be back once you're done. So, best of luck.
Yeah, thanks, Angelo. Thanks for the nice introduction. And before I joined this stream here, I was watching it on YouTube, and I can 100% agree with the quote of Amazon, because this was also one of our findings when we did the white paper, and I come to this later on. But first of all, a few words about myself. I'm one of the founders of FLECS. What we do at FLECS, I'll explain a couple of minutes later. I'm in the industrial automation now for more than 10 years. I was starting as a software engineer. I was product manager for quite a time, and now since almost 3 years, I'm doing FLECS with two other founders. The company also grew a little bit since then. Yeah, and now let's jump into what we do here at FLECS. So I know that this might be a very international audience, but maybe someone of you has ever seen one of those slides here, one of those logos here. If not, the first one is Schneider. That's a German-based, or was a German-based company. The second and third, I think they were UK companies, and all of them, they were world leaders in the development and manufacture of PCs in the 80s and then early 90s. The question is why maybe you don't know those logos anymore, and we discover this now a little bit deeper with the dilemma of the PC manufacturers in the 80s. Everyone developed their own side or controlled everything themselves, from chips at the bottom to say at the very top. And now really the question is why they no longer around today. Because they were doomed by the silos they have built by themselves. Because with the advent of standard hardware and software, developing everything in-house was much more expensive and no longer economical. So there was a consolidation of the market that caused many of these companies to go out of business. I think one of the only companies which survived this was IBM. They managed to do pretty good. They're still existent and they're still running a very huge business. But at the same time, new companies arise like Dell, HP, Toshiba, and you name it, you know, all the big PC manufacturers. So another type of computers are the PLCs, and now we are in the area of industrial automation. These are computers for the control of machines. And here we are in the middle of a comparable consolidation. So in terms of chips, the manufacturers are focusing on ARM and Intel chips. And in terms of operating systems, more and more are using Linux. Most industrial apps are already prepared for this today. And there is currently no uniform channel for sales and distribution. So people are still working in silos here. And this puts many, many companies in existential distress. And that's where FLECS comes in. With FLECS, we offer the fastest growing and so far only independent app marketplace for the industrial automation industry. Another question is, why now? Because we see that the consolidation is slowly moving from the bottom to the top. And there is a growing understanding of the need for a unified marketplace. Large players can afford such a development themselves, while smaller companies fall by the wayside. For them, connecting to the marketplaces of the big ones is usually out of the question for competitive reasons. Yeah, you would never be a customer at your competitor. And that's why no other industrial marketplace is growing as fast as FLECS. Yep, and with our marketplace, we bring the industry apps to the PLC with one click. You see a screenshot here on the right side, and keep them up to date there. And what's in for you as a PLC manufacturer? So first of all, you have your customized automation solution. So that means that you deliver your PLC, your IPC edge device, or even virtual machine with your version of FLECS and provide each customer with a unique automation solution that they can easily extend themselves. And this is now also one of the reasons why together with Zenoh, FLECS and Zenoh are working so good together, because everything that we develop that runs on the devices is also open source. So here we have I would say, a very similar mindset to what Angelo and his team are doing. Second thing is that, of course, we run the marketplace, but you can, as a PLC manufacturer or even as a machine builder, have your own branch marketplace. That means to the customer, you have your branding, you have your logo in front. You can decide which apps are installable on your devices, which not, and you can even offer apps that are exclusively available for your devices here, and you get a full-fledged modern e-commerce platform, including licensing model and subscription model with that. Third one, and now we are getting a little bit closer to what Zenoh does in all of that, is that this solution is very suitable for data management and retrofit. So not every time you have an industrial automation task, you are in a, let's say, greenfield environment. Usually, or very often, we are working in brownfield. So that means we have old devices, old PLCs that needs to be connected. And with FLECS, this is totally possible with our service mesh, and I come to this in 1 or 2 slides later. That is some kind of the data and communication backbone of what we do here. Yep, and in terms of vulnerability and open source scanning, if you have problems tracking the software on your devices, then we are glad to help you doing that, to keep you up to date on vulnerabilities of your system and the apps you have installed, so that you know at any time if there are any security issues on your systems or not, and what to do to get around that. One example of a customer is the Bomer Nürnberg GmbH. So this is actually a PLC manufacturer who uses FLECS inside their controllers. Here you see the BMAX PLC on the right side. And then Bomer has many years of very deep experience in motion control and PLC application in the automation industry. And the solution you see here on the right side included a self-built IEC 61131 programming system. So for those of you who are not familiar with industrial automation at all, this is the programming language you use to program a machine. It doesn't have a very cool name like I don't know, TypeScript or Rust or so. It's very, very uncool name. But the problem of that one was they could not share the motion data with any other application. And with FLECS, the Bomer users can now use all motion control data through Zenoh in real time with all other apps from the FLECS marketplace. Bomer thus offers its customers an open, flexible, and really future-proof solution with the highest performance and safety standards. Now it gets a little bit more technical, and now you see where FLECS and Zenoh work together with each other. So the yellow box is the device you saw in the previous slide. There our open source software stack is running, and this exists of, let's say, 3 layers. The top layer is a web application. That means a very easy to use UI that the user accesses to control FLECS. The second layer is the application layer. That layer is responsible to install the industrial apps, to update them, to manage and monitor them, and also FLECS itself. And the base layer here is, we call that FLECS Flunder, which is Zenoh wrapped in an additional library with additional interfaces that we implemented to it. And this is really the communication backbone between the ISC runtime. So here the motion control actually happens. This can be very fast, like below 1 millisecond. And besides that, we have, for example, HMI apps or databases deployed. Sorry. HMI apps are usually those apps that are running on a display next to the machine where you can control the machine itself. You can see how the machine acts. You can change the production and yeah, control it. And all this data is communicated in real time through Zenoh here and can be accessed either by a specific lib. We have example implementations in C and C++, or can be used with any other connector like MQTT or OPC UA. So this is how it looks inside this box. And now the question is, how did we decide for Zenoh? And I think this is now more than 1 year ago, maybe 1.5 or even 2 years. So we were working with a very, very early version of Zenoh. And then we compared it to other communication layers like MQTT, OPC UA, and yeah, Angelo named them up front. What we were searching for is a layer that was, first of all, easy to use and real-time capable. And for that, we did some performance measurements on throughput, latency, bandwidth, and we compared it with the other protocols, and we compared also the usability. We also we had several things that we compared with each other, but in the first line we compared the real-time capabilities, and what you see here is the measurements with Zenoh 060. Well, Angelo, you can correct me, but I think this version is now more than a year old. So this is really not the latest version that we tested there. And then our version 1.5 is also more than a year old. But those were the measurements we did. Do you have, sorry, do you know when version 0.60 was?
So I think that was early 2022 or something like that. Yeah. And I think that was even before, because 07 we stabilized the API.
Yeah, this was before. Yeah, that was before.
Yeah.
But you can see here the throughput. It was immense. We measured more than 1 million messages per second with small message sizes up to, I think it was 512 bytes. And in industrial automation, usually the messages are not too big. They're most of the time very small, but you have a lot of them. So this is really important to have a high throughput on that stage. And on latency side, it was also very interesting to measure latencies between 31 microsecond and 55 microseconds, I remember. And a couple of weeks ago, I saw that, was it an American university that also did some measurements, Angelo?
So there is NTU, which is National Taiwan University, is top university in Taiwan.
It was
question of maybe guys, you guys can post on social the link to the blog. So they did a paper. There is a scientific publication. They contributed a blog where they evaluated the performance of Zenoh, DDS, Kafka, and MQTT. And
exactly. And I just cross-read their findings, and I think they are very realistic, because what we did there 1.5 years ago was with earlier version, and we did not optimize anything. We just took it as it was and let it run. And I assume that they did some improvements, something to make it run even faster. And I totally agree that this is.
So in their case, no, I think it was off-the-shelf configuration. They just had very fast network, right? It was run on 100 gigabit network. Does the throughput. I think the hardware and the network, it's far it's more enterprise than embedded than what you would find in industrial. But I think it's important to show that we can perform in both environments, and that's one of the goals of Zenoh, right? To be able to run well in high-end hardware and networks, as well as on constrained systems.
Absolutely. So I was very happy, because we did not measure with Kafka, but we compared to DDS and the other protocols, and they had more or less the same findings. And you can see how Zenoh itself improved. Of course, they used a better network in that case, but I'm pretty sure that when we do the same measurements with the latest version, that it will even have improved here. If someone is interested in the white paper, send me a message or ask Angelo to forward the request to me, and I will be very happy to provide this white paper to any one of you. Yeah, and here we have a quote from Jürgen. He's product manager at Bomer. He's responsible for this yellow box. And as you can see, he's very happy with what we are doing here. And he said, being able to exchange the motion data between their system and all the other apps, this is really a USP that they can offer with us, and they don't see with any other system out on the market yet. Yeah, well, here's some references from companies we are currently working with. Some of them are customers, some of them are partners. And now last night, what results did we achieve? As you can, of course, see, updating an automation system is much faster with FLECS, because you just have to click on update and then it will work, and you don't have to use any SSH stuff and things that machine builders usually cannot handle. Of course, the savings are also quite a lot, because when you save time, you also save money. And for the PLC manufacturers themselves, we help them to deliver their PLCs, their new PLCs, 5 times faster they did before. There's a special program we call that FLECScelerator. That's a 6-week program where we, together with a PLC manufacturer, develop a first proof of concept, and after that, everything is up and running. And usually, they want to see the real-time performance of Zenoh. They want to see how they can add their own apps and stuff. Yeah, and this is really the fast track for them. One of the benefits if you're working as a big company with a small startup like us. Yeah, and that's it. As said, my name is Sam. If you have any questions, put them in the chat, and I'll be happy to answer them.
Thank you, Sam. Thank you for your presentation. And so, as mentioned, so we'll thank. We can thank you. So, of course, put your question on the chat. And by the way, look at the chat because we are streaming live on Twitter, LinkedIn, and YouTube. So there will be potentially questions coming on from multiple medias, and you'll be able to answer any of those social medias, as well as on our Discord. So hang on a moment. Let me bring on Rodrigo. Rodrigo, hello. How are you? So
I'm good, thank you. Can you hear me?
Yeah, very well. So Sam, thank you. I'll just remove you from the stream, but
Bye bye.
Yeah, you hang around. Thank you again. Bye.